Hello, everyone, and welcome to today's webinar, Don't Dig a Moat, Stay Ahead of Networking Security Obsolescence. Thank you to everyone for attending. My name is Lauren, and I'll be your moderator today. Before we hear from Connor, I want to go over a few housekeeping items with you. All attendees will be muted throughout the entire presentation, but feel free to ask questions at any time using the Q&A pane on your screen. Connor will answer as many questions as time permits at the end of the presentation. So with all that taken care of, let's get started. Here's your host for today, Connor Cox.
Thank you very much, Lauren, and thank you to everyone for joining today. Today we're going to be talking about managing security and connectivity for multi-site environments. So just kind of dig into some of the challenges associated with that and introduce a new approach from DH2I on how to handle some of those security concerns. So as we are looking at network security, kind of want to define the discussion here to narrow it down to kind of protecting an organization's data and systems. And so, that's kind of the pull that's on the one hand, and on the other side, we have this concern of needing to create connectivity between various users, sites, and clouds. So that's kind of the networking piece, and then you've got the security side kind of on the other hand, and oftentimes those are in conflict with one another. So when we look at something like site to site, we kind of define that as multiple data centers. You may have multiple offices or various different campuses, maybe some subsidiaries that your organization has under management. So that's kind of what we're looking at in terms of site to site. And then managing connectivity for hybrid and multi-cloud, so connecting clouds together. So an on-premises site to the cloud, maybe from one cloud even to another cloud. So those are some of the things that are also of concern when we talk about networking and network security. And then finally, we've got this concept of connecting users. So this idea of remote users, folks that are, those road warriors or individuals who are working from home, all the way to other quote unquote remote users, such as customers. You may have some partners that need access to some of your systems, some of your applications, and even potentially separate divisions that need to be able to connect to some of the IT resources that you have under management. So those are all kind of what we're going to be talking about today, some of those key use cases here for security and for networking. So a very classic approach to managing network security has been the castle and moat approach. So much like castles and moats, this approach to networking security originated a very long time ago. And basically, it goes something like this. Any of the individuals or resources that are outside of this defined network perimeter is considered to be untrusted. So outside of on the outside of the moat, if you will, is untrusted. And anything that's inside the castle or has crossed across that perimeter, across the moat, is considered to be trusted or secure. So essentially what it boils down to is granting various users network access to inside that perimeter. So it has kind of an interesting benefit or positive of being able to really strongly fortify that perimeter, that network perimeter. So you can put up lots of defenses to keep individuals and other resources out of the castle itself. However, nowadays there are more and more different factors that are causing this approach to become less effective. So you have this concept of mobile users, remote users, cloud. So some of those use cases we just spoke about, as well as a variety of other complexities that we'll get into in just a moment here. But first, let's kind of take a look at a visual representation of this standard legacy type approach to network security. So this bold black circle up above here, that represents the network perimeter, or in our analogy, your moat. And then within the moat are the organizational resources. So in this example here, we have a database, maybe there's a machine, an operating system here, and then an application down below. So just a simple example of some of the resources within an organization's quote unquote perimeter that you may be requiring to give access to some of your users. Everything outside, again, is untrusted. And again, a very simple example here, we have several users who are entering the castle, crossing that moat threshold to access the company resources. Okay, so again, the traditional means of protecting and doing so, and you'll also see there's a firewall here that is kind of that pathway through to the inside. So one of the enabling technologies of the sort of castle and moat approach is this idea of a VPN. So since all of the users and sites are not always necessarily on the same company network, this idea of a VPN is required to let people over the moat or into the castle. So very simply, the VPN technology connects the network of one site or user to that of another. The issue is that because the network slice is opened up between the two resources, this opens the organization up to lateral network attacks. So what I mean by that is, if I go back to the previous slide here, if user one is connected via VPN, and let's say they're supposed to have access to this particular database and nothing else. A VPN approach makes it much easier for that user to gain access to some of these other resources inside that maybe they should not technically have access to. So, and there are a variety of means to be able to further tighten that down, but it causes issues nonetheless because of that slice of the network that is being given to that particular user. So castle and moat is great and in theory, but again, if someone or something that is considered bad or undesired makes it in, they can move around within the castle, oftentimes undetected, and they can cause many other issues. So you have situations where perhaps a hacker or a malicious individual makes it in, and they can look around inside your castle and then oftentimes leave without even being detected after they've discovered other vulnerabilities or things that they're trying to access. Another issue with the VPN itself is that it is all very hardware based and based on proprietary hardware. So in other words, it requires specialized hardware that must be configured on any of the connected sites. Not only that, but the hardware itself must be identical on any of the sites that are being connected via a VPN router. So if you are an organization with, for example, many partners who you connect to, you must either standardize on a single VPN platform or manage many different VPN routers. So this is a challenge that many of our folks that we speak to, organizations that I talk to on a regular basis, are dealing with. Is how do I juggle all of these various VPN connections in an environment that may not be completely homogeneous, or that I may not have full control over. So then there is the issue of tightening security through that VPN pipe, which means managing things like access control lists and firewall policies. And so this can carry some significant management overhead for many organizations to just deal with all of those settings as things change, as you add more customers, as you add users. That can be a major headache. And so the last piece here, the last point I want to make on this slide is that in order to secure access to the cloud or between various clouds, customers must rely upon this idea of a cloud VPN. So this is essentially a service that you rent from your cloud vendor. It can be very challenging to manage as well, so it carries its own set of complexities, and it has an added cost, and it can be very expensive because these vendors will charge you an hourly fee to have this VPN connection in place. So every hour that's up, you're being charged, and you'll be billed for that. So just additional costs and complexities associated with a VPN. So if you're still kind of using this moat and castle approach, if you're still using a lot of VPN technology, it's really time to think about considering a new approach. So not only are cloud and multi-site becoming more and more common, but things like DevOps, Internet of Things, containers are also increasing in popularity. And so it's just another factor that's causing folks to kind of rethink this old approach. Additionally, hackers are getting ever better at exploiting customers who use this castle and moat approach. And so really with this new paradigm of how organizations are deploying applications, how their users are connecting to resources, it's really time to sort of, if you will, evolve our networking security methods. So with that, DH2I has developed an approach that we think better maps to these new realities that we discussed and overcomes some of those issues of the moat and castle and the traditional VPN. So what this is a fully software-based technology that allows network administrators to create secure, encrypted, application-level tunnels between users and applications, giving them very granular access to only the applications that they have been granted access to by the administrator or by the policy that's been set up. So the best part about this is that the resources on either side are completely invisible to the outside world. So what that means is that there are no open ports that are required to be exposed. There's no VPN required. There's no direct link in place. And really the outcome here is that the overall networking solution and the overall framework is much more secure and less complex than any other approach. And finally, it's also more performant. And we'll talk a little bit about how and why that is the case when we dig in a little bit deeper into the architecture itself. So a better match for these new realities, this new paradigm for how organizations are deploying and securing their networks. But first, here is an image kind of in contrast to that first diagram that we saw. And so in this picture, in kind of the DH2I approach, each user gets access to the applications that they have been defined to have access to, and no more, no less. So user one has access to this particular database and this application, but that's the only access that they get. They do not have network level access into the inside of the perimeter. all they get access to, all they would see is the applications that they've been designated access to, and then so on and so forth for various other users or applications or servers or services that we need to connect between sites, between users, and between clouds. So what I'd like to do is dig a little bit deeper into how our networking software works. And this solution is called DX Odyssey. So first, again, as I mentioned before, this is all software based. And so the DX Odyssey gateway software is installed on whichever machines that you would like to act as gateways. So we certainly recommend one or more of these gateways on each of the sites that you would like to connect. The second piece here is that the gateway machines themselves will join with one another by registering with DH2I's cloud matchmaking service. Okay, so there's no data that actually ever passes through this service. All it's there to do is to introduce gateway members to one another. And then at that point, the gateway administrator or administrators can essentially create as many tunnels as they wish between the origin and destination sites. Very critically here, DX Odyssey actually leverages, it actually takes the TCP data and it transports it over UDP for a couple of different reasons. One is that it is more highly secure because the data is segmented. It makes it more secure, and it is more highly performant because of the fact that UDP is simply by its nature a more highly performant protocol. And as everything should be, it is fully encrypted as it's in transit using DTLS. So for the local user that needs to access some resource or application, it's on the destination side, they would simply connect to the origin tunnel gateway, and in doing so, they would gain access to that remote resource. So they never actually leave their local network here on the origin site, and the local user doesn't have to have any special software installed on it. It would just simply connect to that origin gateway on some local port, and in turn they would again gain access to that destination. So that's for our on-premises local user. For a remote user, wherever they happen to be, they would then need to install a very small, lightweight agent on their remote machine, and then they would then gain access to whichever tunnels the administrator of these gateways has determined that they should have access to. So they can get out to these tunnels as well. And also, as part of that, they communicate with the matchmaking service to be able to find where their gateways are and what group they are a part of. So I guess before I dig into this next one, just a little bit of background. DH2I has, as a company, has pretty extensive history going back 9 or 10 years now in the high availability space. So the final piece here is that we have sort of applied that background to our networking solution. And so administrators can actually spin up multiple gateways at any of these locations where any of the gateways reside. And then they can create highly available tunnels between those gateways. So the end result here is that connections are never interrupted if a gateway were to go down, because that connection would simply fail over seamlessly from one gateway to another within a gateway group. So high availability is also built into this, which again is very different from the old approach where I have some piece of VPN hardware, and if it goes down, then I'm sort of out of luck. I'm in trouble until I can get that piece of hardware, that router, back up and running. So just a little bit more detail on the remote users on this slide, but really to sort of simplify it, all that the users need in order to connect are the application itself, a set of credentials, and a configuration file that is supplied by the gateway administrator and then can be distributed to the users. Another piece that's very helpful here is the ability to create user groups. So, rather than having to set up each individual user with the access that you've granted them, you can add them into a group and say, all my developers in group A, they get access to, this set of databases or whatever the resource is on the other end, whatever the tunnel is that you've defined for them. So I kind of want to briefly revisit this use case discussion, but apply how DX Odyssey overlays onto these various architectures. So for those cloud, hybrid cloud, multi-cloud use cases, this allows customers to connect their on-premises resources to the cloud or connect cloud to cloud, all without having to rely upon that cloud VPN service. So you can do away with that, increase the level of security, and ensure that you're only allowing granular application level access to the particular applications or servers or services that should be granted access to. Next one is that multi-site use case. So certainly there are a lot of organizations out there that have multiple different sites. They have multiple different data centers. They have branch offices. They have retail stores. Any of those sorts of situations, this can allow for that level of connectivity between those sites without having to open up that VPN pipe, adding a higher level of security and a deeper level of granularity. So even if you do have, say, a direct link between your sites, well, rather than just letting everybody on that network flow between, you could actually just set up very granular tunnels between the various locations. And then finally, remote user access. So talked about this on the last slide, but again, just being able to allow your users to access only the applications or services that they should have access to from wherever they are in the world just makes this much simpler without having to leverage a very heavyweight, VPN type style connection for these folks. Okay, so next what I would like to do is walk you all through a demo to kind of illustrate the solution. So what I'm going to be doing here is I'm going to walk you through the gateway group that I've already created, which is between the DH2I office here in Colorado and an environment that's running in Azure. So I've already got those gateways together. What I'm then going to do is create a tunnel between them from the on-premises gateway to a SQL Server instance that's running in the Azure environment. So it's out here essentially sitting next to this gateway machine that's in Azure is a SQL Server. And then what we'll do is we will connect to that instance. And we'll do so in two different steps. The first will be from a local user in Fort Collins. Okay, so this will be another machine out there called Lab 4. And what we'll do is just connect to that Lab 5 machine and see if we can get to our SQL Server instance. And then finally, we'll move to a remote machine and show you what that looks like from the perspective of a remote user. And we'll essentially define, yes, they have access to this tunnel, and configure them as a user, set their username and password, and then show the process of connecting to this instance from wherever this person is, whether they're on the road or what have you. Okay, but the first part is just taking a look at this Lab 5 and Win1 gateway group. So we'll do that. We'll take a look at the Win1 machine itself. So this is one of my gateway machines. You can see it's the Win1 machine. And we've created this two gateway group. So they've got DX Odyssey installed. And if we look at the gateway manager, we can see a list of them. These both happen to be Windows Server machines, but again, as I mentioned when we were digging into the how it works, this can be a Windows or a Linux machine. So again, software defined, it's all up to you in terms of what your gateways are running from an OS perspective. You can see their private IPs there, the version of DX Odyssey that they're running in their OSs. But again, Lab 5 is in Fort Collins, Win1 is in the Azure environment. Okay, so what we want to do is again create that tunnel. So if we just go into Tunnel Manager and add a tunnel. So when we are configuring this tunnel, we have to set a few different values here. The first being just a simple name. So this is just a logical name for your tunnel, so we'll just call it Azure SQL. And then the information about our destination. So our destination is going to be the Win1 machine, because again, that's in Azure where our ultimately our resources that we're trying to access. And then the target, either hostname or IP address, for where this tunnel is going to essentially end. And so in our case, we want it to go to our our Ubuntu One machine, which is our SQL Server, which has the private IP 10.0.0.4. Okay, so if we go back to our environment here, 10.0.0.4. By the way, this could be local loopback. So if we wanted to just get to this gateway machine on some particular port or some application that was running on it, then we could just add local loopback here. But in this case, we're going out to our application, and our target here is 1433, which is the port on which our SQL Server instance is listening. Okay, so that's all the destination info. Now we are going to add the information for the origin. So in this case, we wanted to originate on Lab 5, which is our Fort Collins data center. Select the network on which we want to allow for this tunnel. So we're saying allow all. And then create essentially a listening port on that Lab 5 machine for SQL Server, or excuse me, for this tunnel. So in this case, I've got a port number that I'm going to assign here, 3433. This last one, we can actually add or create as many filters as we want on this tunnel. So we can say, allow all IP addresses and, or allow all, ranges with certain restrictions. We can say restrict all, but only allow set IP addresses to access this tunnel. But in this case, we're just going to leave it open to anybody essentially on this Lab 5 network that can get to Lab 5 on 30433. We will be tunneled to the destination. So hit OK, and that's all it takes to create this tunnel. So add and remove tunnels very easily. You can see I've got a couple others here that I've configured already, but I can always edit it after it's been created if I need to. Okay, so with that, let's go to, as we saw in our diagram, Lab 4 and see if we connect to Lab 5 on 30433, if we can actually get to our instance. So let's go to Lab 4 and go ahead and connect to, so this is just SSMS. I'm going to connect to a SQL Server instance on my Lab 5 machine, which is again 10.1.135 on 30433, which is indeed the listening port for our tunnel. Of course, we need to authenticate to the instance itself, so username and password. Hit connect, and there we go. So we just connected to a SQL Server instance that's running in Azure. No VPN, no open ports whatsoever. We've just connected locally to a local gateway. So let's make sure that that is indeed the case. Make sure we've actually hit the instance that we're expecting to. So we'll query the server name. We'll just do the version as well. And then the host name that we are connecting from. And we'll go ahead and execute that. And we can see, indeed, we are connected to the SQL Server instance that's running on Ubuntu 1. Happens to be running SQL Server 2017. And we're connecting from our Lab 4 host. Okay. Again, without ever leaving our local Fort Collins network and without opening up any ports on the Azure side. So that Azure SQL Server has no open ports whatsoever, and we don't have a VPN from Azure to Fort Collins. All right, so that handles that first use case of the top half of this diagram, connecting local user in Fort Collins to our SQL Server instance in Azure. Now let's add in this last piece that really completes the story here, and that is a remote user. So in order to set up for a remote user, I need to go back to my gateway software here, and I need to essentially create a new user or new client. So just call this person Connor, assign the password, okay, and then apply that and close that out. Okay, so we have our new client. Now, at this point, we would need to export per gateway group a configuration file. Okay, so I would just do that here and then save it somewhere and then distribute that along with the username, the password, and the installation to my user Connor. And so I've already gone ahead and done that, so you didn't have to watch me copy and paste that config file across to my user. But that would be the other piece that you would need to do. And then finally, go over to our tunnel and manage the clients that are associated with this, clients or groups that are associated with this tunnel. So we'll just go ahead and add a client. And then for the client that we've selected, what port on their local machine will we create this listener, this listener to access this particular tunnel? So I'm just going to use the same one that we had set up on lab 5 and add them to this tunnel. Okay, so you can see that they're set up here. So Connor is now granted access to this particular tunnel on local loopback and port number 30433. So let's go to our user here. So this is a Windows machine, Windows 10. So it's this VM Win10 01 machine. And we're just going to walk you through this remote client installation here, just so you can see what that entails. So next, and install. Yes, we want to allow it. Okay, and then hit finish. So that's it. We just installed, we installed DXConnect on this machine. And so we'll just go ahead and launch it and take a look at what we need to do in order to log in here. So first we need to set the path for this config file. So I've got it here under this folder. So I'll set the path there, my username, and password, and then connect. Okay, so I'm now connected to whatever tunnels I've been granted access to, and in this case, it's just that SQL Server one that we just set up, and I can view that by looking at the status. So in this little window, I'll have a list of all the tunnels I have access to and their names, right? So it just tells me all that information in addition to where that listener is located. So let's see if we can get to that same instance via SSMS, similarly to what we had just done from the lab 2 machine, or excuse me, lab 4. So this may take a moment as SSMS starts up here. But the beauty here is this machine could be, you know, on LTE, it could be really anywhere, and I can get access to my tunnel. Okay, so local loopback, there's my listening IP address 30433. Of course, again, authenticating to my instance. Connect. We can see real time my connection as well. And this is just a VM that's running on my locally on my Mac here, so it's not the world's most performant VM, but nonetheless, we are indeed connected to that same instance. Okay. So that's really completes the map here, this map of the different means of connecting to our application. Keep in mind, I just showed you SQL Server as an example. Some other pretty major use cases for this are things like RDP and SSH. So if I need to get access to, say, a machine that's running out in Azure, maybe I need to get SSH access to this entire Ubuntu machine, or maybe my corporate office has a desktop that I need to get access to. Well, rather than exposing some RDP port to the world, which is a bad idea, or setting up a VPN from my remote device to my corporate network, all I have to do is just set up a tunnel from from my remote user, to the RDP session for a particular machine within my corporate network. So much more granular, much more secure, and more performant. Okay, so I want to discuss a little bit about this concept of software-defined perimeter. So what DX Odyssey does is, in doing this, it really creates a software-defined perimeter. Rather than having that castle and moat perimeter, now I can very easily extend my network perimeter to wherever and whomever should have access and nobody else. Okay. The other piece to that, however, is that there are a variety of other vendors that are doing what they consider to be software-defined perimeter. There is even a group of the Cloud Security Alliance that has a specification for what they consider to be a software-defined perimeter technology. And as you're looking at this, you'll probably run into some of our competitors in this space. And you'll probably think to yourself, well, what makes DH2I, what makes DX Odyssey different than these other things that I'm seeing around SDP, this other activity? So I really want to address some of those head on here. The first and very critical one is that DX Odyssey uses UDP and DTLS for encryption for the data transfer. Any other sort of SDP tunneling solutions out there rely solely on TCP. And we went over the reason why we see taking that TCP data, transporting it over UDP is more secure and more performant, but it is a significant differentiator, for what we actually do. The second piece is all about the matchmaking service. So we have this concept of a matchmaking service. Again, all it does is it makes matches. It introduces servers, gateways, clients to one another, and then lets them transmit data between one another, authenticate with one another, does all of that directly. There is this concept in some of the other SDP technologies out there of a controller. The controller sometimes actually has data that passes through it. Other times it is doing higher order functions that can cause it to become a bottleneck. Not just that, the controller node can be seen as a threat in and of itself. Because it is doing so much, because it is having data pass through it, if it becomes compromised, then you are also really in trouble. Matchmaking service avoids these types of threats, does not become a bottleneck, does not slow your data down, and does not become a potential for further issues. So much more lightweight. And then this last idea is about how our gateways are managed, how they work, really just the nature of the gateways themselves. The first being that we have the unique ability and capability to scale out our gateways for HA and load balancing. And of course, you can always scale them up as well. The next one here is about how this tool can be integrated into existing and future technologies that you may be deploying or will be deploying. Everything that you saw me do today can be scripted, can be managed via CLI, and can be added to any sort of other workflow that you may have in place. So the extensibility, the openness of this tool is much superior to a lot of the others that are out there. And then finally, just all about our ability to support different platforms. So you could be running this in a Docker container, Windows, Linux, Red Hat, CentOS, Ubuntu, whatever you prefer, to get even in a mixed environment. So it doesn't have to be all the same, but to be able to get the performance and cost outcomes that you are hoping for. Okay, so this is just a summary kind of what we covered today, sort of how this can help overcome some of those traditional networking perimeter challenges. But I do want to quickly, before we get into Q&A, is take a quick poll of the audience to understand your level of interest in DX Odyssey. So I'm going to go ahead and launch that. I would appreciate it if you could take some time to respond. And in the meantime, I'm going to just kind of take a look at some of these questions that are coming in, and we can start taking those as they come in. So, Lauren, could you go ahead and start fielding some of these questions as folks are voting on the poll?
Yeah, of course. All right. It's time for some questions. So keep on typing those into the Q&A pane and we'll get through as many as we can. Let's see what this first one says. What is the trial software and how long is that license valid for?
Excellent question. So, and I apologize, I did not get into that yet, but so we have this idea of a proof of concept or free trial. If you want to try, DX Odyssey, you are more than welcome to do so. Set up a couple machines, create some tunnels. It's pretty simple, straightforward stuff to do. But really, the process for that is we will grant you access to our client's portal and then send you some information regarding where to find downloads, where to access your license key, etc. And you have access to fully featured software. So it is not a reduced feature set. It is everything that the full product can do. And you will have access to that license key for 30 days. So that's kind of how our proof of concepts work. Additionally, we are always available to help with installation, configuration, if you have design questions, other support as you need it. We're here to help with that too. So yeah, certainly encourage trials for any folks that are interested. Get your hands dirty. It's really the only way to prove that this stuff works is to do it yourself. So it's always an option to you.
Okay, let's find another question. Does it support IPv6?
Yes, good question. Everything you saw today, I was just using IPv4, but certainly this supports IPv6 as well.
Okay. Is there a contract term or do I pay for usage?
Sure. So The way DX Odyssey is licensed is you pay annually depending upon either just the gateways that you're using or a combination of gateways and users.
Okay. How are you administering the gateways/routers?
Sure. So in terms of administrating the gateways themselves, that's kind of what you saw in the demo, right? Is just going in using the DX Odyssey management console. By the way, there is a client version of the administration console. So you don't necessarily need to run that from your gateways themselves. And then, of course, as mentioned, you can do any of these things via the API as well.
Okay, here's another question for you. Are you supporting Mac and iOS?
So currently, we do not have a completed Mac iOS client support, but that is coming very soon.
Okay, let's see. Does it still work if my gateways have no access to the internet?
No, so in order to create a tunnel between various different sites, the gateways need to be able to go out and register with the DH2I matchmaking service, and that is done over the internet. So without internet access from your gateways, they won't be able to find each other, and you won't be able to create any tunnels between your sites.
Okay, good questions, guys. Do clients need to install something on their machines to access these tunnels?
So it depends, right? So if I am a local user, if I have access to the network on which my origin gateway resides, no, the client doesn't need to install anything. If you are a client that is remote, in other words, if you're not on that local network, yes, we have the lightweight DX Connect tool that you will need to install and then log into to be able to access any tunnels you've been granted.
Okay. Here's another question for you. What are the installation prerequisites for a DX Odyssey gateway?
Very good question. So for Windows, we require .NET Framework 4.5. And so that would be a requirement for a Windows gateway. And then on Linux, similarly, you would need .NET Core 2.1 on Linux. And in terms of support for the Linux gateways, as I mentioned before, Red Hat derivatives, so things like CentOS, as well as Ubuntu 16 and 18.
Okay. How would you generally size the gateway machines? I know you can scale up or out, but they're not sure where to start.
Sure. So we generally would say start with something relatively small. I mean, you don't really need to have a massive gateway machine here. If you start with say 3.5 gigs of RAM on a server, that would be more than adequate.
Okay, let's find another one. How many clients can go through a DX Odyssey tunnel?
So as many as you wish. So there's no hard limit on a gateway. In terms of clients or tunnels, that's all really up to you. But of course, you would need to either license that gateway for for unlimited clients, or essentially set up a client license for each one of those clients that's accessing it. And I see it looks like we do have some questions about pricing and licensing. So I think while we're here, we might as well just go through that so that you guys can just have an understanding of what this thing costs. So let me go ahead and share a screen here. All right, so you should be able to see my screen, but essentially what we have is two separate pricing models for the X Odyssey. So the first is essentially you pay for the gateways on a per gateway basis, and then each one of your clients, each client that's accessing any gateways, any tunnels, would then also need to carry a license. So how we would do that is we would say $250 per year per gateway. And then for the users themselves, we have two separate prices depending upon the level of support that's required or desired. So the first would be kind of your standard business hours, email, web support, and each of those users would cost $60 per user per year. And then we have a more enterprise grade 24/7 support that also includes phone support, and that would then be $100 per user per year on that first client server model. The second licensing model is simply licensing the gateways for unlimited users. And similarly, we split this out into the two tiers of support. For the lower tier, $2,500 per year per gateway. And then for the 24/7, including phone, that takes you up to $3,000 per year per gateway. So all in all, pretty affordable, really, when you look at it. Set up some gateways and do so without a VPN. It's a pretty reasonable cost for what you get.
Okay, thank you, Connor. We can get one more question here before we run out of time. What's the gateway capacity?
So we don't really add or subtract from any sort of, we don't have any sort of limit really in terms of the capacity of the gateway. It's really just the capacity of the gateway hardware itself. So we don't add any additional overlay overhead on top of that. So yeah, we don't limit the capacity of a particular gateway one way or another.
Okay, well, thank you for everyone for joining us. That's all the time we have for today. If you have any additional questions, feel free to reach out to us. If we didn't get to your question, we will reach out to you personally and answer that. We'll also be following up with you shortly with the recording of this webinar. Thank you again for your participation, and we hope to see you at our other upcoming webinars.
Thanks, everyone.